Okay, so in this video we want to look at sketching linear graphs, which hopefully should be relatively straightforward, something that you've looked at a couple of times before now through our years 7, 8 and 9. What I do want to do though is get rid of some of those annoying and unnecessary habits that you've established throughout years 7, 8 and 9, where often I find students are greatly overcomplicating what needs to be done when sketching a linear graph. So in order to sketch a linear graph, in fact, anytime we sketch a graph, we must have enough information labelled on the graph that would enable someone to work back from the graph to the equation. Okay, and so the minimum amount of information we need on a linear graph is 2 points. If we have 2 points on the line, we can calculate the equation of the line. Okay, so whatever the line is, you want to make sure that you are always labelling at least 2 points on the graph. Okay, now the other convention that we have with graphs, whether they are linear graphs, quadratic graphs, cubic graphs, all sorts of other graphs that we'll look at this year and over the next couple of years, is that whenever we draw a graph, we must always label the axis-intercepts. That is, the y-intercept, the point where the graph crosses over the y-axis, and the x-intercept, the point where the graph crosses over the x-axis. So, if we have to, when we sketch a linear graph, we must label 2 points, and if we must also label the x and the y-intercept, then they should be our 2 points. We don't need any other points, okay? Unless the x and the y-intercept are the same point, or we only have one intercept, then we will need to consciously label a second point. But if we need 2 points on a line, and our line has an x and a y-intercept that are different, then those are the 2 points we're going to label. So therefore, we want to calculate the x-intercept and the y-intercept before we sketch our graph. It's really important that. Please don't, every time students see sketch a graph, often students straight away they draw, their axes like this. Now, if your intercepts are such that your y-intercept's here and your x-intercept's here, and you don't need any of this and you didn't need any of that, then you should have thought about it first and drawn suitable axes. So you calculate your intercepts first, and then you think about what your axes will need to look like, okay? So we already talked about in the previous video, the y-intercept is the value of y when x equals 0, because the y-intercept is the point where the graph crosses the y-axis. The only thing we know about the coordinates at this point is that the x-coordinate must be 0. It has an x, sorry, that was a terrible straight line. It has an x-coordinate of 0, okay? We don't know the y-coordinate. So we substitute x equals 0 into the equation to work out when x equals 0, what does y equal, and therefore that's the coordinates of the y-intercept. The x-intercept, on the other hand, is on the x-axis, which is where the y-coordinate is 0. So we don't know the x-coordinate, all we know is that the y-coordinate is 0. So again, we go to our equation, we let y equal 0, and we work out what x has to be, so that then we've got the coordinates of the x-intercept. So we do those two things first, then we know where we're drawing our graph, we draw suitable axes, and we rule a straight line. If you are not very good at drawing fairly straight lines by hand, use a ruler, okay? I will say that to my Year 12 students as well heading into their exams in November. If you cannot draw a straight line as a straight line by hand, use a ruler, okay? Alright, and I say that to them because the VCAR examiner's report says that as well. Okay, so let's make sure that we're drawing straight lines when they should be straight. Sketch the graphs of each of the following, clearly labelling the x and y intercepts. Okay, so the first equation is in gradient intercept form. So we know the gradient's 2, which means it'll go up as it's positive 2, so it goes up as we go from left to right. So I'm going to clock that in my head, but the gradient is not useful. Well, it is, but I'm not going to use it at all in sketching my graph because it's not a feature of the graph I'm going to label. I need the y-intercept and I need the x-intercept. Okay, so I'm going to calculate those two things. Y-intercept is easy when we're in gradient intercept form because when we let x equal 0, that bit there disappears and we get y equals 4. So the coordinates of the y-intercept will be 0, 4. Again, I said this in the last video, but we want to build a habit of always labelling points on graphs with coordinates because, again, in Year 12, in those VC exams, VCAA will always ask for graphs to be labelled with coordinates. And if you don't label with coordinates, it's not correct. So let's build that habit now so that by the time we're at the end of Year 12, every time we sketch a graph, we always label coordinates without even thinking about it, and we're never going to have that issue later on, okay? Alright, we want the x-intercept, which is when y equals 0. So I'm going to let y equals 0, I get 2x plus 4. Subtracting 4 from both sides, negative 4 equals 2x. And dividing both sides by 2, x is equal to negative 2. Negative 4 divided by 2 is negative 2. So the coordinates of the x-intercept, the x value is negative 2 and the y value is 0. Okay, so we need an x-intercept at negative 2 and a y-intercept at positive 4. So we need positive y-axis and negative x-axis. So I'm going to draw a suitable set of axes. If I can't draw a vaguely straight line, I'm going to get a ruler out. I'm just going to move that over the other side, it'll be out of the way of the graph. And then I'm just going to draw a line where the y-intercept is roughly double the x-intercept. Okay, I didn't do any scaling, you don't need any of that because there's only 2 points you need to label. This point here at 0, 4 and this point here at negative 2, 0. And that is our completed graph. Okay, very, very quick and easy to draw once you've calculated your points. Okay. The scale on the x-axis does not need to be the same as the scale on the y-axis. Though when you're drawing a linear graph, I would want to give a sense that, you know, this value is roughly, sorry, I meant to highlight, that this value is roughly twice this value, okay, just to give that sense, but it doesn't need to be perfectly twice. It could technically, if we want, it could technically look like that, as long as that's labelled as 0, 4 and that's labelled as negative 2, 0, okay. We are just using a different scale along the x-axis compared to what we're using on the y-axis, okay. And that's perfectly fine. The issues are you need to be consistent within the same axis. So if we were going to draw another graph here, which went through the point 1, 0 and the point, so went through 1, 0 and, you know, 0, 8, we would then need to be consistent with the scale we've established. So we can't all of a sudden make this 8 and this 1. Okay, because it's not consistent with the fact that this has defined that that distance is 1 on the x-axis and that distance is 1 on the y-axis. Once you've established, you know, what the scale is by marking 1 point, then everything else needs to follow through with that. Okay. All right. So we've got our first graph. Found our x and y intercepts and drew the graph. Now, the second example, the graph is in general form. In my experience, 80% of all students, the first thing they will do is convert this to gradient intercept form, which is a complete waste of time. And I would say that 50% of those 80% of students will do the rearrangement incorrectly, and or the rearrangement ends up with fractions, which it will in this instance, and they struggle with fractions and they then don't calculate the x and y intercepts correctly. Okay. It is completely unnecessary to change to gradient intercept form because remember, this is all we need to sketch the graph. We let y equals 0 to find the x-intercept, we let x equals 0 to find the y-intercept, and we can do that just as easily leaving the equation in its current form. Okay, so the y-intercept happens when we let x equal 0. 3 times 0 plus 2y equals 10. I wouldn't even write out that line. I can see when I let x equals 0 that that term's going to disappear and I get the equation 2y equals 10 and therefore y equals 5. Okay. X-intercept is letting y equals 0. 3 times x plus 2 times 0 equals 10. Again, I wouldn't write out that line. I can see immediately from the original equation when I let y equals 0, that term's going to disappear and I get the equation 3x equals 10. You can immediately write down these two very simple equations for finding the x and the y-intercept, which can be solved very, very easily. You do not need to know the gradient in order to sketch the graph. You do not need to rearrange it to gradient intercept form. I cannot say that more frequently. I say it repeatedly and still students persist. When you rearrange this to gradient intercept form, like I said, you're going to get fractions. You're going to get negative 3 on 2x plus 10. Okay, yes, y-intercept is, plus 10 on 2, which is 5. Okay, yes, y-intercept is 5, but we found that so easily here. 2y equals 10, y equals 5. Done. And then when you find the x-intercept, you're now trying to solve, that's 3 on 2x, this equation, which I guarantee you lots of you will do incorrectly. Whereas here, all we had to solve was this equation, which is easy. This equation, hard. So you've wasted time rearranging. Even if you've rearranged it correctly, you've then created a harder equation through which to find the x-intercept, okay? Please don't do it. Please don't do it, okay? Use the general form. So we've got our y-intercept at 0, 5. We've got our x-intercept at 10 on 3, 0. It doesn't really matter how big 10 on 3 is, but if it helps you, 10 on 3 is 3 1/3. So this is 3 1/3, this is 5. They're both positive. So thinking about where my axes need to go, something like that. That's 10 on 3, which is about 3 1/3, which is exactly 3 1/3, sorry. And that's 0, 5. Okay, I've given the rough sense that this value is bigger than this value, not a lot bigger though. 5 is just a bit bigger than 3 1/3. And I've labelled my intercepts with their coordinates. When a question says clearly labelling the x and y intercepts, it doesn't mean that you write y-intercept at the y-intercept. It means that you label with the coordinates. You want to label the location of the y-intercept, not that it is a y-intercept. We all understand what a y-intercept is. You don't need to tell me it's a y-intercept. When it says label the x and y-intercepts, it means label with the coordinates, okay? Alright, let's have a look at some other special variations. So graphs where we get only one intercept. So for example, y equals negative 3x is an example of that. If we were to find the y-intercept, if you think about this as being in gradient-intercept form, that's just plus 0, so you can tell that it's 0 straight away. Or you let x equal 0 and you get y equals negative 3 times 0, which is 0. So the y-intercept is at 0, 0. And then for your x-intercept, if you let y equal 0, you're going to get 0 equals negative 3x. Dividing both sides by negative 3, 0 divided by negative 3 is still 0, and so 0 equals x. So it's still 0, 0. So the problem that we get here is the x and y intercepts are the same. So we haven't got 2 points. And remember we talked about a graph always needs 2 points. Now you can find another point very easily simply by substituting in any value of your choosing. Okay? I often use x equals 1. When x is equal to 1, y is going to be equal to negative 3 times 1, which is negative 3, and so therefore the graph goes through the point 1, negative 3. That's another point. You could let x equals 2 and find that y equals negative 6 and mark the point 2, negative 6. You could let x equal 1.7 and find that y equals whatever 3 times 1, negative 3 times 1.7 is, and mark that point on the graph. You could sub in x equals negative 10 if you want. It doesn't matter. Any other point. Okay. You could also use the gradient to find your second point. So the gradient is negative 3. So we know it goes through the origin, has a gradient of negative 3, which means for every 1 step across, we go 3 steps down. So it's going to go through the point 1, negative 3, which is the same thing that we found by substituting 1 into the equation. Okay. So you're going to have 2 points and you're going to join them up. Let me draw that slightly more precisely. Okay, so I am going to draw a nice square axis this time because my graph is going through the origin, 0, 0. And it has a gradient of negative 3, so I'm going to mark this point as being 1, negative 3, and there's my line. Conventionally speaking, you don't have to label the coordinates of the origin. We all understand that that is the point 0, 0, so it is fine to not label that point. That's the only point where it's okay to do that, but equally, you know, it would be perfectly fine to label 0, 0. Y-axis, x-axis. When you draw a straight line graph, can we make sure, please, that the minute you draw your axes, whether they look like this, whether they look like this, whether they look like this, okay, you have defined the sort of drawing space for your graph, okay? When you draw your axes, you define the space for your graph. Now, a straight line graph goes on and on forever. So please make sure that when you draw in your straight line graph, it doesn't just stop in the middle of nowhere for no apparent reason. Make sure that it extends all the way to the imaginary box you've created with your x-axis, okay? Your axis. Make sure we're extending all the way to the edges of that box. We don't want to just see a line like this because I'm wondering, why does it stop here? What are the coordinates of this point? Is there a reason for it stopping here? If there isn't, it should continue all the way to the edges of that imaginary box, okay? You can put arrows on the end of it to indicate that it keeps going. You don't need to. Just extend it right to the edge of your axis, okay? Also, don't be stingy when you're drawing your graphs. They don't need to be tiny, They don't have to be huge either. Just, give yourself room so that you can label everything accurately, that everything can be clearly read. Particularly, I hate it when I see graphs like this and everything's so close in here and I can't even read or see what's happening. Give yourself room. Again, that's about the planning, so we can actually see what's happening and label it properly. Alright, example 4, we're looking at for the line y equals 5. Now, we can think about this as being in gradient-intercept form. This is y equals 0 lots of x plus 5. So it's got a gradient of 0 and a y-intercept of 5. Okay, so a line with a gradient of 0 is horizontal. We talked about that in the previous video on gradient. So it's a horizontal line with a y-intercept of 5. Horizontal line with a y-intercept of 5. I'm going to make sure that it looks parallel to my x-axis. So that's my x-axis. That's the y-intercept at 0, 5. Now, I have said to you that we should always label all linear graphs with 2 points. Probably one exception is horizontal and vertical lines, but equally, there's nothing wrong with just labeling a second point here to be 100% clear that this is a horizontal line, okay? And you could pick any x value. That could be the 0.15, that could be the 0.75, that could be the 0.995, it could be the 0.65, it doesn't matter. It could be, 7.25, whatever. It's just another point with a y coordinate of 5. I might go with 3, 5. You could label -1, 5 over here, or whatever it might be, okay? But again, 2 points means there's no ambiguity about what's happening with the line. It's clearly a horizontal line. Now, this can be a helpful way to think about it, but actually, I just want you to think what this is saying. I'm drawing a line on the Cartesian plane where the y value is always 5, okay? Students often mix up and they think y-axis is vertical, y equals 5 is a vertical line. Think about what it means, okay? The y value has to always be 5. Every single point along this horizontal line has a y coordinate of 5, okay? So it's a horizontal line. Same logic then, if I'm drawing the line x equals 4, I want to draw the line where all of the points have an x coordinate of 4. So that's going to be a vertical line. Sorry, not 0, 4, 4, 0. That's going to be a vertical line. Every single line along this point has the same x coordinate, and that x coordinate is 4. Again, best to label a second point for whatever you want. 4, 2, 4, 10, don't really care. Those 2 points have the same x coordinate, therefore it must be a vertical line. There's no ambiguity then. It's not actually a line that's just got a very, very steep gradient and will meet somewhere down here. It is actually a vertical line. As I said, conventionally you'd probably get away with just labeling the intercept, the one intercept, and drawing a clearly horizontal or vertical line, so a line that is clearly parallel to the x or y axis. But then you're not going to lose marks for marking on a second point. This one you definitely need to mark on a second point. We need to be able to tell that that is the graph of y equals -3x as opposed to -5x or -2x or -7x or -100x. We need to have enough information to be able to tell what the equation of that line is. Okay, one more example, a sort of worded problem thinking about linear graphs. Sam is earning some money picking apples. She gets paid $10 plus $2 per kilogram of apples that she picks. If Sam earns C dollars for n kilograms of apples picked, complete the following. We want to first of all write a rule for C in terms of n. Okay, so there's lots of things that we've talked about through the earlier algebra lessons here. We've talked about constructing formulas. We've talked about this phrase in terms of. So C in terms of n means C equals, and whatever's over here is going to have n involved in it. Okay, so let's think about she earns C dollars, so that's her earnings. Okay, it's not a good letter for earnings. It's not really cost, is it? But anyway, she earns C dollars when she picks n kilograms of apples. So we know that she gets paid $10 no matter how many apples she picks. So her earnings are going to be $10, plus she then also gets $2 per kilogram. So $2 for every kilogram. So if she picked 1 kilogram, she'd get 2 times 1. If she picked 2 kilograms, she'd get 2 times 2, $4. If she picked 3 kilograms, she'd get 2 times 3, $6 added on. If she picks an unknown quantity of kilograms, n kilograms, she's going to get 2 times n dollars. Okay, so plus 2n. So there's our formula that connects the amount that she earns with the number of kilograms that she picks. Part B, we want to sketch a graph for this range of n values. So the point here is we just want to sketch the graph for a specific range of n values. So it doesn't make sense here. When we've got an application problem, I'm just going to do a rough sketch. If this was n and this was c, it doesn't make sense to draw a line where you get negative n, because n is the number of kilograms of apples picked. She can't pick negative apples. So there shouldn't be anything back here. So we want to draw the graph only from 0. And then we're going to cap it. So that's what this is saying. N, the number of kilograms, has to be bigger than or equal to 0, but it's also going to have to be less than or equal to 20. So n has to be between 0 and 20 inclusive. Okay, and that's really because we're essentially saying, well, in the practical sense, there is some upper limit of how many kilograms of apples she could feasibly pick in a day. And the question here is defining that upper limit as being 20 kilograms. There's no way she's going to pick more than 20 kilograms. The model doesn't apply after that. Okay, so we want to sketch the graph just between n equals 0 and n equals 20. So let's just think about the graph first of all. So c equals 10 plus 2n. Now that's the same as c equals 2n plus 10. The letters are different, but this is the same as sketching the graph of y equals 2x plus 10. Gradient of 2, y-intercept of 10. In this case, gradient of 2, c-intercept of 10, because our vertical axis will be labelled with a c. Okay. So we're going to have our c-intercept, we know, is clearly 0, 10. Our n-intercept would be 0 equals 10 plus 2n, taking away 10, negative 10 equals 2n, dividing by 2, n equals negative 5. So if we just drew this graph, let's forget about the restriction for a minute. We just drew this graph, it would go from negative 5, y-intercept at 10, sorry, c-intercept at 10, n-intercept at negative 5, 0. But we're not interested in negative n. It's not relevant to this problem. We only want to draw this graph from n equals 0 up to when n equals 20 to work out the y value there. And we're not going to draw any of this back here. Okay? So we're actually only going to draw a line going from where n is 0 to where n is 20. So the 2 points that I'm actually interested in here are when n is 0, which we've found, okay, and when n is 20, which will be the end point of the graph. When n equals 20, c is going to be 10 plus 2 times 20, which is 10 plus 40, which is 50. So it goes through the point 20, 50. So we're going to draw a graph, n and c, okay. This is going to be 10, 20, 30, 40, 50, just to get my scale right, because I am going to have 2 points. We're going to go from 0, 10, which is there, that's the c-intercept, up to, now I'm not going to do, it doesn't really matter how big I make the 20, I'm going to go with 10, 20 sort of, okay, up to this point at 20, 50. Now, you could label this as 20 and 50, but I want to really discourage you from that. It's not very precise. Again, let's label all important points on the graph with coordinates at the point. It leaves no ambiguity about what's happening. Okay. And that's the graph of the amount that she earns, C, compared to the number of kilograms that she picks, N. Okay, use your rule to find the amount that Sam earned after picking 9 kilograms of apples. Okay, so here's our rule. Our rule connects the amount she earns with the number of kilograms. So this is about simply substituting. This means n will equal 9. So it's c equals 10 plus 2 times 9, which is 10 plus 18, which is 28. So therefore, Sam earns $28 on the day that she picks in 9 kilograms of apples. It's not a very good rate, is she? Is it? She's probably a backpacker being paid pittance in pre-COVID times when we did have backpackers picking fruit. Okay, part 2, find the number of kilograms. So again, reading the question, we read the stem and then the peak that comes after it. So use your rule to find the number of kilograms Apples picked if she earned $45. Okay, so again, our rule connects the amount she earns with the number of kilograms. In part 1, we were told the number of kilograms, we calculated the amount she earns. In part 2, we're told the amount she earns, which is C, and we need to find the number of kilograms. So this time, 45 equals 10 plus 2n. So substituting into our rule, and now we need to solve for n. Let's take away 10 from both sides. That gives us 35 equals 2n. And divide both sides by 2. N equals 35 on 2, which is 17.5. So therefore, Sam picks 17.5 kilograms of apples. Okay. Alright, so the work today is from exercise 1F. Again, the QR code there is linking to an older video on sketching linear graphs if you want to watch another explanation, but hopefully most of you are okay with what you've seen here. So exercise 1F, the list of questions there. Just before we move on, I'm just going to quickly address sketching linear graphs using your CAS. We will talk more about using the CAS in the next video, and having at least had a go at sketching a couple of graphs with your CAS is important, would be helpful. I would never use my CAS to sketch a linear graph. It's so easy to do by hand, but let's use this as a gateway for sketching other types of graphs down the track. So the first thing is to open a graphing page. So if you're working in document mode, you're either going to start a new document by pressing Ctrl-N and then choosing 2 to add a graphing page to that document, or you're going to insert a new page into your existing document by pressing Ctrl-I, and then you're going to select 2 to insert a graphing page into that document. I work in the Scratchpad because in Year 10 Maths and throughout Maths Methods, we only need to use graphs and calculators. So I prefer to just keep everything nice and neat in here. So in the Scratchpad, we're going to press the Scratchpad button to toggle from the calculator screen, which is where I was, across to the graphing screen. Now, if you're in luck, your CAS will immediately have opened up the entry line. You can see there it says F1 brackets x equals, and that's where we're going to type in our equation. What's really important to understand, and we'll look at this in more depth because this is something called function notation. We're going to actually look at that in the next video. But the F1 of x essentially replaces, which is how we read that F1 brackets x, we read that as F1 of x. It's function 1, which is a function in terms of x. It's got x in it, okay? That replaces y. That is the y equals. And we don't want to change that. There's real advantages to the fact that our CAS uses function notation. We'll introduce that in the next video. It's really important to efficient use of your CAS, and also function notation is really important in terms of being able to write efficient maths on the paper throughout your Maths Methods course. We'll see it quite frequently. So, if you can't see that entry line, you're going to press, so if that's not there, you're going to press Tab to open it up, or you can press Control-G to open up that entry line, okay? We're going to leave that F1 of x and we're going to write our equation. So let's sketch the graph of y equals 3x minus 5 first of all, okay? So I'm going to leave, instead of y, it's going to be F1 of x equals, and it's going to be equal to 3x minus 5. 3x minus 5. And we can see the graph. Okay, so if necessary, we might adjust the window. Let's come back to that. I'm going to change the graph to something else and I'll come back to that. We can explore our graph, that is find the key points, using in a couple of different ways. We can use graph trace, menu 5.1 for graph trace. And what that does is it places a cursor on the graph. The cursor will always start at the y-intercept, so we can see the coordinates of that point on the bottom right-hand corner of the screen. The y-intercept of this line is clearly 0, -5. And then we can scroll, just using the cross arrows, along the line. Depending on your settings, it'll jump in different increments. You see mine is actually jumping in increments of 0.3. So we're there with x equals 0, I hit across, I go to x equals 0.3, I hit across, I go to x equals 0.6, across, x equals 0.9. Okay, so it just moves across in increments of 0.3. However, it will automatically find, so x equals 1.5, but it's going to automatically, it didn't move along this far, it automatically jumped to the x-intercept. Now, actually we're seeing two CAS tricky things here. The first is that your CAS's graphing screen can only work in decimals. And so what we've got there is a rounded decimal for the x-intercept. Now, if I wrote on my paper that that x-intercept was 1.67, it wouldn't be correct. I wouldn't mark that correct because in maths methods, we always want to give exact answers unless the question instructs us to give an answer to 2 decimal places. So actually, if we think about doing this by hand, 0 equals 3x minus 5, 5 equals 3x, and x is 5 on 3. That's the exact point that we want to label. So we would do that by hand, or in tomorrow's video, I'll look at introducing how we can use that function notation to do that very quick, get our CAS to do that algebra very quickly for us. The other problem we're seeing here, which is I'm glad it's introduced it here, is we're seeing this number here, 1e negative 12, okay? When your CAS writes that, it's using standard or scientific notation, and that means 1 times 10 to the power of negative 12. We'll review scientific notation in a couple of topics' time. So essentially, that is dividing by 10 12 times. So it's the number 1, divide that by 10 12 times. So it's going to have 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the 1. It's a teeny, 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 tiny number. And it's just a flaw of your CAS in some of the mechanisms it's using to find this point. It is a tiny, tiny number. We know if that's an x-intercept, it should be 0, okay? It should say 1.670. So we need to understand that. We need to understand that we don't write 1.67, so we're going to use some algebra to work out that's actually 5/3, and that y value is actually 0. Okay, so it can be a bit confusing. We can find out other points in graph trace mode. We can just scroll along it. You'll see when it gets to the x-intercept, it says 0. Another word for x-intercepts are zeros of functions. That is where the x value is 0. Sorry, not the x, where the function equals 0, where the y value is 0. If we scroll and we get to the y-intercept, it'll tell us that that's the y-intercept, to be specific about that point. Okay. Just quickly, I'm going to hit delete 3 times, 1, 2, 3, and it'll ask me, do I want to delete everything? Yes. Let's just draw another graph quickly. Let me draw the graph of y equals, let's go with half x plus 8, and we're going to get that. Okay, so we've got a window issue here that we actually can't see the important parts of the graph that we need to see, which is the x and y intercept. So we're going to need to adjust our window. Now, don't use zoom. I don't advocate zoom. Sometimes it works, but it's hard. You lose a lot of control over your window. I would use menu 1 for window settings, and here you can adjust the minimum and maximum x values and the minimum and maximum y values. You can also adjust the scale, so how often you'll see a tick along the axis. However, if you don't need to make a lot of adjustments, it's quicker to do it on screen manually. So I know the y-intercept is at 8, so I need a bigger maximum y value, bigger than 6.65, which is what it is currently. So I'm going to scroll up to this value using your touchpad, and I'm going to click on it once, which will select it, and I'm going to click on it again, which will enable me to edit it. And I'm going to make it a number bigger than 8, so I can see clearly the y-intercept at 8. So I'm going to make it 10. You could even make it bigger than that if you wanted. Now I can see my y-intercept clearly. If I then want to adjust this x-intercept, now I might do some quick calculations in my head, and I know that x-intercept is at negative 16, but there might be a bit of trial and error for you, but you want to try and use what you know. I'm going to need to adjust this value. I'm going to click on it once to select it, click on it again to edit it. I'm going to make that negative 20. And now I can see all of the important parts of the graph. Okay. You can also use Analyze Graph, menu 6.1. Okay. So this is, sorry, I should have shown you what I chose first. Menu 6.1 for zeros. That's going to enable me to find the x-intercept. It asks me, it brings up this vertical dotted line that moves around as I move my cursor. It's asking me for a lower bound, okay? That means I want to move this vertical line so that it is somewhere lower than the x-intercept, somewhere a smaller x value than the x-intercept. So down here to the left of the x-intercept somewhere, and I'm going to click, and then it changes and asks me for an upper bound, and you'll see now I've got another dotted line moving with my hand. And it's giving me this shaded area. So essentially I'm giving it a range within which the x-intercept will happen. Sorry, I accidentally clicked there. Click somewhere to the right, and then it'll mark the coordinates of the point of the x-intercept at that point. So negative 16, 0. There's no Analyze Graph option for y-intercept. You would use Graph Trace, menu 5.1 like we did before. It puts your cursor on the graph. Now usually it will default to the y-intercept. as the first point that it goes to. If it doesn't, we could either scroll until we get to the y-intercept, or when you're in trace mode, if I want to get to the point where x equals 0, which is the y-intercept, when I'm in trace mode, so I've pressed menu 5.1, I've got this sort of hatch, this crosshairs cursor, I just type the number 0. I'm not doing anything else than pressing the number 0 on the keyboard, and automatically up on screen appeared x equals 0, and when I press enter in trace mode, it'll jump me to the point on the graph where x equals 0, and I can see at the bottom right there those coordinates. Okay, so have a bit of a play around with your CAS and some graphing. We'll do a bit more CAS work throughout the next video to come. Okay. So as I said, bit of cleanup here, delete, delete, delete to get rid of your graph, and then I would go to menu, 4 for zoom, and 5 for zoom standard to set my screen back to a standard graph. And then, when you come back to it, that's where it will be. Okay, it's been a longish video, but hopefully the nuts and bolts, you watch that first and you could come back and dabble with the graphing section towards the end afterwards. Please, when you do the work in this section, so this exercise 1F, please sketch those graphs by hand. Okay, I want you to sketch all of those graphs by hand and sketch them on your paper. Don't use your CAS, do all the calculation by hand. But perhaps after that, go back to a couple of the questions and have a play around with the CAS, seeing if you can get your graph to show up properly on your CAS calculator as well.